exponential functions. Okay, and the main things that we know about exponential functions is that they have a non-constant rate of change, and the other thing is that they are multiplicative, meaning they are either multiplying or dividing repeatedly. Okay, and what we've learned this week is that exponential functions take the general form of y equals a times b to the x power, okay? Where a, you've learned, is the y-intercept or initial value, right? So we know that that's when x equals 0, and b is going to be something called our growth or our decay vector, okay? Now, this is going to be the amount that we multiply by or we divide by repeatedly in order to change, right? Growth would be a function that is increasing, and decay would be a function that is decreasing, okay? So when we do this, what we want to be able to do is find both the y-intercept and the growth factor in order to create an equation. So let's say for number 1, we have a table. And in our table, we have some x values and some y values. My first x value, let's say, is 1, 2, 3, 4. I know that 1, 2, this would be 4, 8, 16. So if this is the table we're given, right? We need 2 pieces of information. The first piece of information I'm gonna find is I'm gonna find the pattern, which is gonna give me my growth or decay factor. So when I look here, I see that we're multiplying by 2 every time. So I now know that my b value here is 2. Now, the only other problem I have is I need to find my a value, which is my y-intercept, right? But I don't have it. So we need to go backwards to find when x is 0. So if I'm moving backwards, I know that I need to actually divide by 2 to find out that our y-intercept is going to be 1/2. Okay? Now, once I have these 2 pieces of information, I can write my equation. Y equals 1/2, and then we can just say times my b value is 2 to the x power, and this would be our equation, right? So if we wanted to do another example like this, could be x, y, 0, 1, 2, 3, 4, and if we start 3, 9, 27, 81, and 243. Okay, so my first step here is always to find the pattern. So I see 3 to 9, I multiply by 3 times 3 times 3. And since I know that means that this is multiplicative, right? We're multiplying repeatedly, it has to be exponential. So my b value is 3, and my a value, this one is a little easier because it's actually in the table. So I can just look here and say a equals 3 because this is my y-intercept, right? So we make our equation y equals 3 times 3 to the x power, and so on, okay? Now, sometimes this is not going to be increasing. Sometimes it's going to be decreasing, right? So if I had a table that looked like this, and we have 16, 4, 1, and 1/4. So I look and I see that this is going down now. So this has to be exponential decay. The other 2 so far have been exponential growth. Okay? So when we look at decay, I see what's happening here. We are actually going from 16 to 4. We're doing division by 4. 4 to 1, we're dividing by 4. Okay, but I can't put that in my equation as like divide by 4 instead of where this 3 is, right? So instead I need to think, how can I write divide by 4 as some sort of multiplication, right? So if we want to go from 16 to 4, I actually am doing the same thing as multiplying by 1/4 or 0.25. So this is actually times 1/4 each time, times 1/4, right? So now I just found my b value is 1/4 or 0.25, whatever your preference is, right? And my a value is easy. That's just my y-intercept here, which is 16. So all I have to do now is we have y equals a times b to the x. We just plug in. So my a value is 16. My b value is 1/4, and I put it to the x power. And I can close my parentheses. You also could have written this as y equals 16 times 0.25 to the x. It is the exact same thing and would be totally fine, right? But when we're dividing, we need some sort of fraction or decimal to show that we're getting smaller each time when we multiply by it, okay? The last thing that I'm going to show you, which we'll go over in greater detail tomorrow during class, is that sometimes you are actually multiplying by a percentage, right? So we learned in class that when you're multiplying by a percentage, it is exponential. So if I start with 0, 1, 2, and 3, let's say I had $100 in my bank account, and every single time it's increasing by 3%. So my table would look something like this. This would be 103, 106.09, and then 109.27. So what we know is happening every time is times 1.03, because that is a 3% increase, okay? Or we could find it by doing some division that we'll go over in class tomorrow. But if I look at this, I can do the same exact thing. I know my a value and my b value. My y-intercept is 100, so that's a, and my b value is now this 1.03, or a 3% increase. And what we should remember is the 1 represents the 100% you start with, and this is the 3% that you go up, right, the increase. So when we write our function, we just write y equals 100 times 1.03 to the x power. Okay, and this we could use to find the bank account's amount in any number of years. But writing exponential functions is actually pretty